So, good morning. Today we are here to talk about control charts. My name is Katie Labedz. I'm the president and CEO of Learning to Lean, a lean consulting firm based out of Hortonville, Wisconsin. I am a certified Lean Six Sigma Master Black Belt and certified project management professional. I'm also an emotional intelligence coach, and I'm proud to say I'm also an author. I've written 3 books: How to Improve Absolutely Anything, How to Improve Absolutely Every Process, and the Learning to Lean CI Planner. They're all available on Amazon. I have over 20 years of experience in project management, continuous improvement, leadership, and coaching because I started when I was 12. So that's what we're going with today. So today we're going to be talking about making your data visible and control charts. So we are going to walk through what are control charts. I'm going to show you some real life examples. And then I'm also going to show you how to do it in Excel. So that's probably the biggest question that I get is how do you do them in Excel if you don't have a statistical tool like something like Minitab? So let's get started. So let's talk about what are control charts and how do we use them in our projects or really in our day-to-day life. Let's give you a little history. We need to know where they come from. So they originated with Walter Shewhart. So he founded what we know as statistical process control, or SPC. He developed them as a technique for analyzing observational data, so data that we can observe. He framed the problem in terms of assignable cause and chance cause. So, what he used it for was working at Bell Labs. He wanted to bring the processes into a state of what we would say statistical control, where there's only chance cause variation, and we'll go over that too, and keeping it in control to produce or predict future outcomes. So, one of the things I like to talk about with control charts is that it can help you predict the future. Really, it is a tool that is so powerful that by looking and analyzing our data, we can predict the future with our processes. And it's almost like we had a crystal ball to be able to say, okay, we know that we're going to have a problem here. So it's really interesting and a very powerful tool. Honestly, I don't think people use it enough. And I think part of it is because they're worried about how to make the control chart look in Excel or in a statistical tool, which we'll cover today. It's less than 10 steps to do this.
Oh,
So what are they? So they're a graph that's used to study how process changes over time. And data is plotted in time order with a center line for average and upper and lower control limits based on historical data. So, what I like to tell people is I want you to think of an EKG, right? So, whether you've had one yourself or you've seen one, you know what an EKG looks like, right? We have that gentle ebb and flow of our data. And if you look at an EKG, it'll have an upper and lower control limit or a line, and that's based on your age, your gender, your race, etc. So we don't necessarily have historical data for ourselves, but we do have that data from a historical perspective based on those criteria. So we know that we want to see the gentle ebb and flow, and that's what the doctor's looking for. What he is also looking for is changes in that data. So as we look on the screen here, we see the normal heartbeat. That doctor is looking for if you have a fast heartbeat or slow or irregular. My husband has AFib, so we were able to see that. Of course, I'm the nerd that asked the doctor for the data. Can I please see the data so I can look at that and understand it and be able to relate to that in class? So it really is just like an EKG of your data for work. Now, when we talk about control charts have upper and lower control limits based on historical or reference data. Control charts do not have specification limits. So spec limits come from a customer requirement. Control charts don't use spec limits. So again, spec limits are from a customer that they may say, I need this dimension of a part and it has to be between here and here. Those are your upper and lower spec limits, not control limits. That information is based purely on a customer requirement, not on historical data. So what do they look like? This is a typical control chart. Not scary. It's data plotted over time. That's all it is data plotted over time. And it has a line in the center. So here is our teal line to show us the average. And then we have an upper and lower control limit, which is plus or minus 3 sigma from the center line. And I'm going to go over an easy way to calculate this in Excel. And what we do from here is we look at this data and we try to interpret it. And we look at it and say, what's changed or what's really going on with this data? Anything that, and we're going to go over how to interpret the data here in a few minutes. But just initially looking at this, we already know something's going on right here, right? So the data point has gone above the upper control limit. And we may have a few other things. Now, remember, we would never see our data all in a straight line. So you're never going to see a data points in a straight line on your average for the entire data set. If you do see that, that means you haven't looked at your data in enough depth or detail. As a good friend of mine used to say, if your data is in a straight line on a control chart, then you're dead, right? So I'm
Right.
going back to the EKG. So you want to see that gentle ebb and flow, and that's just called noise, but we are looking at special cause when we have a big spike or up or down. So that's really what we're looking for to say, what's going on right there? So the question that we are trying to answer by looking at control charts is what changed? So control charts can help you to identify by looking at your data what changed, when it changed, potentially why it changed, who changed it, trends in your data, good or bad, and if it was a blip or a continued negative change to your process. When you make process improvements, you're going to gather your data again and create another control chart. So your data on your new control chart should visibly change based on your process updates. So that's the cool part of this is that we can make changes and immediately see those changes reflected in our data and on our control charts. So it's a very, very powerful tool. Sometimes we're going to look at control charts and we'll be able to say, this is where we put in a new machine on a manufacturing line. Okay, that explains why we have some strange data, but we expect that data to settle down and settle out. Sometimes we can look at it and say, oh, we got a new system. That's why we have some strange data. Okay.
Yep.
Sometimes I've seen it when factories have multiple shifts. So we can see changes in the data from first to second shift, second to third shift, and then back to first again. That data will show up on the control chart. So again, it's not about assigning blame. This is just about looking at process and process improvement opportunities to understand what changed from one day to the next. A lot of people tell me the setup was great, everything was running well on Friday, whether it's a system or it's a process on a manufacturing floor or it's a report for finance. And we came in on Monday and all the wheels fell off the bus. Everything was fine Friday, and then Monday, nothing worked. So that's when you would use the control chart.
Mm-hmm.
If you're familiar with a normal distribution, I think this is kind of neat. So that's the control chart on the left we just looked at. A normal distribution on the right. Now, a control chart really is just a normal distribution turned on its side. So where we see the 1 sigma away from the average, 2 sigma away from the average, and then 3 sig plus and minus 3 sigma away from the average. So it's kind of neat. You just take your normal distribution and turn it on its side.
Mm-hmm. Yep.
So let's look at some real life control charts. So on the left, we have a control chart for cesarean sections from a hospital from 1998 to 2000. So we can, again, look at data plotted over time. That I would say looks pretty normal. So we have that gentle ebb and flow. We may have a few things happening there, but I wouldn't necessarily panic if I saw that.
Mm-hmm.
Then we have lab processing time. And as we look at that, we can say, there might be something going on here. Uh,
Yep.
we see some data points that are acting a little strange. And then all of a sudden, we had a data point drop off at observation 40.
Mhm.
So it could be that they knew they were having a problem. And at observation 30, whatever data point in time that is, they made a change to the process. So now their data points are getting lower. So this could be reflective of process change in a good way, or this could be reflective of the wheels fell off the bus in a bad way. So,
Yeah.
but we do want to be able to identify these areas and be able to talk to them to say, this is why the data changed. Now, if this was a positive change, you would expect over time your upper and lower control limit to change because now we're having better performance.
Yep. Makes sense.
And then this one is X days to pay insurance claims. So many of my customers are insurance agencies, beyond manufacturing and agriculture and IT and HR and banking. I thought this was interesting. So average days to pay insurance claims over time. Do we have a problem? No, not necessarily. I think it's pretty stable. We'd like to look at some statistical values for this, but over time, I would say it's pretty stable. I would ask what happened here, and somebody I'm sure would be able to give me that data information. That one's just approaching the upper control limit of 63 days. So let's just be able to identify and explain the data point, and then honestly, I wouldn't worry too much about it. Real life control charts. If you make investments, go on your 401k. This is what I did this morning. I went on my 401k and I was like, okay, I need a control chart.
Yeah.
They aren't very good at showing your upper and lower control limit, though that's on there. They don't really show the average line, which would be nice.
Yeah.
But this was interesting just to go ahead and look at that this morning to be able to take a look at an investment versus the index versus the category. So it's there. I don't know that people really recognize that that's a control chart. And of course, for your health, you can have a control chart. I have many friends that use a Dexcom monitor and they're able to have that control chart on their phone to be able to see it. I'm fortunate enough that that is not something that I have to do. However, I thought this was interesting because I was having some problems with glucose and A1C, and this in this area here is where I made a change.
Mm-hmm.
So I was put on some new medication, and then that brought my regular fasting glucose down.
Yep.
So, and that's what we wanted it to do. Now, again, there's only what, three, five, six data points. So I'm not going to have historical data necessarily over time. It's not enough data points. So that upper and lower control limit is based on my age, my race, my gender, etc. So,
Mhm.
and those will change over time too as you get older. Now, there's different types of control charts. The typical ones, like we just looked at, and what you would normally do is called an X bar and R chart. So X bar, or X with a bar over the top of it, means average. So we're looking at the average, like we said, the center line is the average over time or over a range of time. There is an X bar and S chart that shows the average in sigma, an IMR chart, which is individual and moving range, and then a median control chart. But for the most part, all of us regular folks are looking at X bar and R. And that's what you'll see when you're looking online for charts, or you're looking in books or references, etc. Now, if you don't have this book, I highly suggest that you buy it. This is less than $20. It's on Amazon. It's called the Lean Six Sigma Pocket Toolbook. It is fantastic. I explain it as, for those that remember, it's the Cliff Notes version of all the stuff you need to remember for Lean and Six Sigma. So it's a pocket guide that's about this big. I have it in my bag over here. I carry it with me, and it's great little cheat sheets for things that we would use from a Lean and Six Sigma perspective. So on page 123 in that book, it talks about a decision tree over how to select a type of control chart. So
Oh.
I thought that was very helpful. It depends on if you have attribute or continuous data, which we'll look at here in a second. So again, highly recommend that book. Another page from the book looks at the formulas for things. So the IMR chart, which we just talked about, the X bar and R chart, which is the normal ones, and then the X bar and S chart. So it gives you those calculations in there. Now, if you're using a statistical tool like Minitab, you don't have to worry about calculations. It's all done for you. You load the data, hit the button, and out comes your charts. For an average person, Minitab is not, I would say, easily accessible. It is $1,200 a year for a license. So Excel is a lot cheaper.
Yeah.
Attributes charts. So we looked at variables. Now we're looking at attributes charts. There is a P chart, an NP chart, a C chart, and a U chart. So there's examples on the screen also. And all of this information, when we're done, will be posted to YouTube in case you need to reference it again in the future. So a P chart measures the proportion of defective parts or pieces within a group. Okay, so pieces either conform or are rejected. So they're good or not good, go, no go, pass or fail. That's what we're looking at in a P chart. Now, this can be for many different things. It's, again, not just about manufacturing. We can look at this from an IT perspective, from an HR perspective. The one that comes to mind is drug testing. Do they pass or fail? Sometimes we do skills tests. Is that pass or fail? So you could use a P chart for that. An NP chart, which is bottom left, number of non-conforming units. So they're the number of rejected units in a sample. So if you're in a lab, one of my clients is they're the largest exporter of bull semen in the world. So they are looking at the number of conforming units. So we all know what the units are. So they can have an NP chart. Really interesting area that not everybody thinks about, but it's definitely in the medical world and in genetics where we're looking at things like that. C chart measures the number of defects within a sample. And U chart, which you see on the right, is appropriate to use when we're looking at defects rather than defectives. So defective means it's not usable. Defects means there's a flaw and there's a possibility that we may be able to rework it. So interesting, depending on what problem you're trying to solve, depending on what type of data you have. If we go back to our little book, page 132, we are looking at the formulas for those graphs that I just went over with you. So nobody expects you to be able to memorize the formulas, but they are there if you need those for reference. So control charts helps us to see variation. So control charts we're always asking that question, what changed? And we don't want variation in our processes. We want repeatable processes with predictable results. Just like when we make coffee in the morning, right? We don't want any surprises. And that's really what control charts are helping us to monitor of whether or not we're going to have surprises. So we're going to go ahead and watch a video. So special cause variation can be attributed to real changes or differences in a process where we said, think about what changed. So special cause is also known as signal. Common cause is noise, special cause is signal. It's not random. It appears because of specific circumstances. It's usually caused by an outside force to the process, like driving to work and taking longer because you got a flat tire, or here because of construction, or maybe it took an hour to download the report today, but or download the report in the past, but today it took 2 days to do it because there was a problem in the data center. So common cause is noise, special cause is signal. In the analyze phase of DMAIC, we review our data to see if we have common or special cause. And the question we always ask is, what is your data telling you? So there are a large number of rules that are out there, over 20 rules that if you look in some of the statistical books, they talk about how to interpret control charts. So it's beyond just looking at, is a data point above or below the upper or lower control limit. And so in the Lean Six Sigma Pocket Toolbook on page 133, they start to give you some insight to what you should look at. And it's really interesting, right? One point of beyond zone A, so they have the different zones in there that they're explaining to you. Um, 2 or 3 points out of zone A or B. So it's not as simple as, is it above or below the upper or lower control limit? This interpretation gets you into your data even deeper to help to solve your problem. So we use control charts to see if our process is in statistical control. So when somebody says to me, my process is in control, in my mind, I translate that to it is statistical control, not what we would say, oh yeah, it's under control, right? Because we kind of just offhandedly say that. When we say a process is in control, we mean statistical control. So that means that it's predictable. So it's stable and consistent. So we only have common cause variation and no special cause variation. So again, we are in statistical control when both the average and variation are stable. We have common cause variation, that gentle ebb and flow or noise, no special cause. Trends that we experience, because they can happen, it could even happen because the temperatures changed outside. They can be corrected with process, equipment, material repair, or replacement. Now, one way that people use control charts, if you are in healthcare or in manufacturing or really any industry that uses some type of machinery, that we know that parts on those machines wear out. So whether it's servers or it's tooling on machinery, or it could be equipment in a hospital, we know that parts wear out over time. And if you were looking at a control chart for that piece of machinery or those parts or that server, you're going to be able to see its performance change. So that would be a leading indicator to you that something's happening with that device. So I have a customer that we were doing a Kaizen event for, and the participants were talking about a press and how about halfway through the month, they're going in and they're manipulating the settings on these devices. Now, keep in mind, they do PM or preventative maintenance. And basically, what they were telling us was that the machines were coming out of calibration before the PM was done. So that is a leading indicator to us that they needed to change how often they were calibrating that machine. It's a big, giant machine, lots of parts that are moving, lots of things can go out of calibration. But it was really interesting to not only listen, but to look at the data so that those folks could make a better decision on their cycle of preventative maintenance. So let's talk about control charts in Excel. So the first thing you need to do, and we're going to switch over to Excel in a minute and look at mine, is to download your data to Excel. So from whatever report that you have, you can also use, like I mentioned, Minitab, or there's some functions within BI you can use. But today, because most people have Excel, we're just going to look at that. If you're working to solve a problem, you need at least a quarter's worth of data, but probably more. So I get that question all the time. How much data do I need? Well, how long has your problem been happening? So if you say your problem's been happening over the last month, I definitely want to see the data for months prior up to this month. So I can look at that trend over time. So at least a quarter's worth of data, probably more. Now, keep in mind, you're probably not getting the population, all of the data. You're looking at a sample. Remember, you're looking to understand what changed over time. You want to format your data so that you have column labels or column headers. So if you use Excel all the time, you know what I'm talking about. That helps Excel when we do a chart. And then you need to do some calculations. These aren't hard calculations at all. So for all of your data, you need to find the mean or the average. We're just going to use the average function in Excel. So thank goodness Excel has cool functions now, and we can use average. Then you need to calculate your standard deviation, and you are going to use a standard deviation for a sample because you probably don't have a population. So we use the standard deviation formula, and you put in your range. Again, we're using the standard deviation of a sample of data, not the entire population. Then we do our upper control limit, and we're going to follow 3 sigma. So it's the average plus 3 times your standard deviation. Your lower control limit is the average minus 3 times your standard deviation. So all of this is not hard, right? We use formulas all the time in Excel. Even if you flubber it up, you're going to be able to figure it out. So not hard. So right now we have columns of information. For the one we're looking at my website traffic. So the first column, or column A, is the date. And the second column is basically the number of times in that day that somebody came to my website. And we'll click over to Excel here in just a second. So once you have your data in there, so we're going to select our column of date, in my example, and page views. And I'm going to create a chart line with markers. Okay, so very easy, line with markers. And then I'm going to add a column. So before I had my average, upper and lower control limit, and standard deviation at the bottom of my data. Now I'm going to add columns for the average, the upper and lower control limit per row. And then I'm going to utilize the $ or hold to freeze the data. So I don't want this data incrementing for average, upper and lower control limit. I want it to be the same for every row. When I've taught Excel many years ago and continue to teach it, I tell people, just remember that the $ in a formula or in a cell reference are like jail bars, right? That keeps that cell from changing. So that's why we want to use the $, because it's like jail bars. It keeps that data from changing, and we don't want that data to change. For each row, we wanted to know the overall average, the overall upper and lower control limit, because that's going to help us to finish our chart. So once we have that data entered in, then we're going to click on our chart. And this is my chart that came out, and I'll show you in a second. And you want to draw the data selector to select the previous data plus the 3 new columns. So in Excel, before, you had to do some magic manipulation to be able to get these other lines to appear. Now it's much easier. Excel has gotten smarter over time. And it will add those lines to the graph for my upper control limit, my lower control limit, and then my average. And then you can format the data series to remove the markers and change the width. So let's pop out for just a second and go into Excel. So can you still see my screen in Excel? Okay. So here's my data. So my original data, I'm just going to hide this for a second. My original data looked like this. Okay. So I had my date, my page views, and down at the bottom, I had my data average. So I used average. My standard deviation, I used the stdev.p. So standard deviation, you can use it of a population, or you can use it from a sample, depending on what you have. So we're going to change it per sample. My upper control limit was my average, right, plus 3 times my standard deviation. My lower control limit is my average minus 3 times my standard deviation. And then I added in those other columns. And I have my average, my upper and lower control limit. As I said, I used the jail bars to lock that cell reference into place, so it did not change. And what I did, so we'll just do it like this first. So I highlighted my data and I went into insert, and here's my charts. I'm going to go to my line chart and I want line with markers. Easy peasy. Most people know how to do that. Now I did my calculations. I added them in as other columns here. I'll bring this up a little bit. And the cool part now in Excel, which wasn't always there, is that I can select my data. So my data is there. I'm clicked on my chart. I can pull my data selector over and it automatically puts in the lines. So before, it never worked like that. You had to do all this manipulation.
Yeah.
But now it does. So it's cool. So I'm going to go in there and I'm going to click on that. This is my upper control limit line. I'm going to format the data series. I'm going to change, and I don't want any markers, so no markers, which means no dots. I'm probably going to change the width, maybe make it a little smaller. And I can do that for each of my lines here. So I don't want the markers on there. I'm going to go down there and do the same. And you can add data labels. Most people know how to use the data labels feature. So you can add the data labels for upper and lower control limit. And then of course you can add a title. Most people know how to do that. So not hard. There's my control chart, right? So I can look at this and go, wow, there was a really good hit, somewhere between the 19th and the 6th of June. I had a lot of people visiting the website, and then another really big spike here. So what was I doing, or what did I do to drive that traffic to my website? So I'm trying to answer the question, what changed, right? So that's how you can use Excel for control charts. Not hard, just takes a little practice. Again, we're going to download our data, get our average, standard deviation, upper and lower control limit. We're going to add in that column of data using our jail bars to lock in those numbers. First, we draw a line graph, then we expand to do the average, upper and lower control limits, change the data lines to take out the data points, and you're good to go. Not hard. Much easier than what it used to be.
Yeah.
Yeah. Okay. So control charts. Finishing up, what is your data telling you? Really, again, it's interesting if you look at data over time for investments, if you look at data over time for the economy, if you look at data over time for your health, right? Your data is trying to tell you something. And for most of us in our life and our work, we have lagging indicators, which meant it's already happened and now we got to deal with it. Control charts are a leading indicator, right? So it does give us leading and lagging depending on how you look at it. But it's really telling us something's changed. And if we don't do something to fix it, it's going to stay broken. Or we did a great job fixing it and it actually worked. So you want to look at your data and figure out, is it common cause or special cause? Again, common cause, gentle ebb and flow, it's good to go. Special cause means signal, the Batman signal, something's wrong. Do we have any trends that we can take advantage of? Is it in statistical control or out of statistical control? And is your process capable? Does it fall within what you deem capable at work or at home? So thank you for joining me today in our really quick session on control charts. We have free sessions every month. You can find those on my website. It's under training. You can hit the QR code there. I offer continuous improvement training, Lean and Six Sigma, project management, emotional intelligence, coaching, Kaizen events. I am a world experienced speaker, so I'm so honored to have been able to travel the world and talk with various companies and various industries about utilizing these concepts for revolutionary results. Thanks for coming to today's session, and we'll see you again next month.
Thank you. Bye.
Bye.